So the first presentation today is up with Bill, BE1YY, and Jason, BE1PYE. They are going to talk to us about the 630 band. Jason was first licensed in '94 and is heavy into experimentation and vintage equipment. Much of the equipment that you saw in the display room is Jason's equipment, and it's all operational. It's pretty impressive. You can check him out on Doc on YouTube's, as well as his QRZ account. He's also our Halifax Amateur Radio Club's first vice president. Bill has been a ham since 1957, so almost since I've been alive. His main interests are DXing and on the HF bands, but since COVID, he's been working on the 360 meter band. He's interested in propagation, antennas, transmission lines, and he's a wizard on this. I got the opportunity to take in his presentation at Smart 23 when April this year, and it was well received by everybody. So Bill's going to lead off and start the presentation, and then Jason will bring in a strong second.
Good morning, everyone, and first of all, I want to congratulate the Halifax Amateur Radio Club for two things. Number one, achieving 90 years as an amateur radio organization. That is fabulous. Number two, putting together this great day in 2 days that we're going to have together, fellowshipping all about ham radio and what we're all up to. So our pitch to you is that a frontier awaits. It is a frontier that at one time was amateur radio territory, along with the folks who were transmitting on Spark out to the ships at sea. And as you might remember, the powers that be decided, no, we don't want those hams there. They're causing too much interference. So we will relegate them to where they can't possibly get out of their own backyards. We'll send them to 1.8 megahertz and higher frequencies. And of course, we proved them wrong. But joy, joy, circle of life goes around, and once again, we get to play our games with the medium frequency band. If we can have the next slide, please. Next slide, please. So our encouragement today to you is to try the 630 meter band. And in all transparency, I just want to clear up something here. I was active on 630 meters for quite a while, had a lot of fun. When COVID came along, things went the other way, so I got off of 630 for a while. And then those sunspots increased dramatically. And I thought, you know, this would be a good time to finish that 5-band DXCC. So that's what I'm doing right now. Until about a month and a half ago, I started making DX contacts on 6 meters. So now I'm up there fooling around. Perhaps a year from now, I'll have something to say about the 6 meter band. May I have the next slide, please? So our outline today is that I'm doing the overview of the 630 meter band, and then we'll have actual stations presented to you. I'll show my station, and then Jason will come up and demonstrate his. Next slide, please. So where is the 630 meter band? Well, it's a medium frequency band. It's below the broadcast band. It's from 472 to 479 kilohertz. So if you're familiar how the AM broadcast band behaves day and night, This is how this band tends to behave. The band allows a maximum radiated power of 5 watts, and the bandwidth of the transmission can only be 1 kilohertz. So you're not going to be doing single sideband transmissions down here. You'll be doing CW, and you'll be doing digital communications. Next, please. Now, there's some beliefs about this band. Slide, please. There's no one on it. You will find there are people on it. Next slide, please. There's no application for this band. You'll find that it is being used for experimentation of various sorts. It's even being used for message passing, such as using NIVIS antennas. And next slide, please. And you might think there's no DX on this band. So no one on, no application, no DX. Next slide, please. All this is false. Next slide, please. The 630 meter band indeed is active. Slide. Here's a shot taken in February of this year showing DX activity. You can see, first of all, from Alaska, all the way down to Australia and to New Zealand. There's a good contact there both ways. In the United States and in Canada, you can see there's a lot of two-way transmissions going on there. So the band is indeed active. Next slide, please. Now, propagation on this band is by 2 modes. One is the ground wave, and the other is sky wave. That is, there is ionospheric refraction. Next slide, please. Now, with ground wave propagation, you think about the AM broadcast band. Many of you started out in this hobby listening to a radio during the daytime and seeing, oh boy, well, I can hear all the way to St. John. How wonderful. But at night, you were hearing CJOB in Winnipeg. Wow, the magic of radio. And that might have been the kind of thing that caught your attention and the romance of this wonderful hobby. So that's how this band tends to behave. So during the daytime, tens of miles, 50 miles, something like that. At night, hundreds of miles, 1,000 miles. We live next to an ocean. Talking to Europe is, well, I wouldn't want to call it easy, but it can be done. Next slide, please. So during the daytime, the D layer is the big player, and signals tend to go out from your station, and I wouldn't say are ducted, but they tend to be between the D layer and the surface of the Earth and propagate out until they're so weak you can't detect them anymore. But at night you have the E layer. And if we could have the next slide. So at night we have the E layer, the D layer is gone, and you do get ionospheric refraction, as I mentioned earlier. That can give you a couple thousand miles, 1,000 miles of propagation. Next slide, please. So what do you need to get on this band? Well, you thought maybe I was going to say hardware right away. But what you do need right away is attention to losses. Inscribe that in your brain, attention to losses. Attention to high voltages. We'll see why in a little bit, why this is so important. And attention to detail. And finally, being aware of fire. Next slide, please. Yes, some of these antenna matching units that we build and some of the currents that we put through them tend to not just radiate off into space, but go into the losses of the system. And the system gets hot, and we make fire. This doesn't happen too often at 630 meters, but it does at our other band, 2,200 meters. In fact, they have a club called the Hall of Flame. Next slide, please. So the most important thing, other than that attention and watching for fire, is you need a good antenna of some sort, a ground, a tuning and matching system of some sort also, and a transmission line, not to denigrate having the transmitter and receiver attached to the end of that transmission line. Next slide, please. So the antenna that I used was this one here. It's called a Marconi T, and mine was 8 meters high and 30 meters wide. I like to say sometimes it was 10 meters high. It was attached between two trees. So if the trees moved opposite each other, we'd stretch the antenna, we'd go up to 10 meters. If the trees were going towards each other, it sits down to about 7 meters. So to be honest with all you folks, let's call it 8 meters. And the vertical part of the antenna is the actual radiator. And the top part, for many of you know this, is called top loading. The idea is to get the current loop on that vertical part to come up higher on the wire. Get it up higher. The radiation now is up here rather than down warming the grass. And that helps a lot to get your signal out, obviously. So that top part is just top loading and helps to get the current up the vertical part. Next slide. So, we talked about getting that current loop higher, better signal, better radiation resistance, and the better radiation resistance, and I'll repeat this many times, is the greater the efficiency of your whole system. We'll talk about efficiency at some length in the next couple of slides. Next slide, please. So my antenna, that lovely Marconi T, if I were to redo it, I would do what every ham does, get it higher, okay, and bigger. I would put more top loading on it, so rather than that one wire going like this, put another one across, so have maybe even put 3 up there to get more top loading on the antenna. The other thing I might do is on that vertical part, instead of that one wire, take 2, 3, 4 wires, hook them together with some kind of insulators, maybe shaped like this, to make what is called a cage vertical. And when you get a fatter antenna, you get better radiation resistance, and it's easier to match it to your transmission line. And the other thing I would do, and I'll talk about this more, is pay a lot of attention to reducing losses. Can I have next slide, please? Excuse me. Now we're talking about the ground system. Next slide. Next slide, please. So the ground system that I'm using is actually part of the ground system that is under my butternut HF9V vertical. And as some of you know, that's a 28-foot high vertical, good for 80 through 6 meters. And what you're seeing here in this picture is a pipe that comes down and goes into the ground, and just above that is where the vertical actually is connected. You also see the radial plate. That's a hunk of aluminum, and the radial wires are connecting to that. And there's 46 12.4 meter long radials. That's a good start on coming up with a radial field for a vertical antenna. And every now and then you'll see me out in the backyard maybe putting down a couple more. And my wife will say, "What are you doing out there?" Of course, my answer is growing a better vertical. Take care of it. You also see a piece of copper pipe sticking up. That's the so-called DC ground. It's connected by coaxial braid to the radial plate. There's 2 of them, and essentially set up to drain off any static load that's getting built up on the vertical itself. So I can, next slide. If I were to do my ground system again, I would probably get a sheet of conductive metal or screening and put it right underneath that ground plate, that radial plate, connect it to the radial plate, and maybe make it about, 2 meters by 2 meters, 4 square meters. Bob Sherwood, in an article in Ham Radio Magazine a long time ago, and I've talked to him on the radio since then, and he's still using that technique of a hunk of some kind of ground screen, even copper window screening. I don't know where he finds copper window screening. Chicken wire he's used, all kinds of things, and spreads it out in various directions. And of course what that does, it reduces the losses close into the antenna where you've got the most current density. So I'd probably do that next time. Other thing I want to do is reduce any other losses I have there. So instead of using that copper braid, I'd probably want to use copper strapping, something that's got some width to it. And you can see the other kinds of things that I would like to do up there. Copper plate the backyard would be a good idea, but not going to happen. The other thing is I would want to use better fasteners. The kind of fasteners I've been using are solder lugs and stuff like that. I think I should be using more compression fittings. That might help a lot. Next slide, please. I want to show you what happened at that aluminum radial plate. And I had to improve this quite quickly after one season. What you're seeing here is the galvanic action between the copper wire that was made into a loop and then held down with stainless steel nuts and bolts and washers. And it reacted there in the presence of water to the aluminum plate. If you look to the left of that, you can see some less serious corrosion, and to the right, very little corrosion. So that's a spot where you get a lot of resistance and a lot of losses. So you have to overcome that. I had to overcome that. Next slide, please. And eventually figured out that the way to do this is make sure we don't have dissimilar metals touching each other. And so this setup now, you can see the solder lug there, where it's actually a crimp lug. And everything else is stainless steel hardware up against the aluminum plate. Next slide, please. So once you got the antenna and once you got a great ground system, you're going to want to bring the whole thing to resonance. And also you want to match the antenna to your transmission line. Next, please. So you all know that we want to resonate for two reasons. One reason we want to resonate the antenna system against the ground system is to maximize the current flow going up and down that vertical wire. More current flow, more radiation, more distance, okay, more overcoming noise at the other end, more opportunities to have a good conversation with somebody else. People don't think about the fact, though, that by resonating the antenna, you are also improving the antenna system's sensitivity to signals. We don't think about this anymore because our receivers are so darn sensitive. But actually, if you match everything better to your transmission line, to your rig, whatever it might be, you're going to transfer more energy to the radio. So you get a double bonus out of this. Next slide, please. So these antennas that we're using, in terms of wavelength, are very, very small. And being very small antennas, they're very capacitive to ground. And the thing you got to do in order to resonate it, of course, and you all know this, is to add some capacity, add some inductance into the system to cancel it out. These antennas, these very little antennas compared to the wavelength, are very narrow banded. You're not going to work the whole 630 meter band without having to retune the antenna as you change frequency. And the method that I used in order to do this retuning as I moved about the band was to use a variometer. Next slide, please. So the variometer is essentially 3 inductors in series, and I'll show you a picture shortly. With one of the inductors that's in between 2 of the other ones is variable, so I can turn it at right angles, and it doesn't add or subtract to the inductance of the whole coil. If I turn it so that we're aiding the magnetic fields, then I can increase the overall inductance. And if I turn it 180 degrees, where I'm not aiding, I'm bucking the overall inductance, I get less inductance. So I can tune through the entire band with this kind of setup. So you get many inductance values. Next slide, please. So this is what mine looks like. It's a 5-gallon bucket. And this 5-gallon bucket is wound on the outside with essentially household wire, number 14 wire. And you can also see that all the fittings here are brass fittings. And the reason they're brass is because, as you know, there's a strong magnetic field around an inductor. And if those were steel fittings, they would be heating up. And your energy that you're trying to radiate in space is now heating the hardware. You don't want that. That's more losses. And I remember when I was a very young ham, taking a screwdriver and pushing it into the coil of my antenna matching just to see what would happen. And yeah, boy, the tuning went all crazy, and the 5R4 tubes and the transmitter started to glow a little bit. As I slid it in and out, I was obviously tuning the thing. Oh, what's this I'm feeling in my hand? Wow, things were getting hot here because this steel screwdriver was absorbing energy from the magnetic field. So that was an abject lesson. Don't put ferrous metals around RF carrying coils. Now I'll zoom in. If you give me the next slide, what you see there is a container that used to have cashews in it, and it's wound with 2 coils of 17 turns each. They're in series with each other, and they're on an axle that you can see. And all the coils then with those 2 coils and the coils on the outside are all connected in series. Next slide, please. Now the other thing we got to do once we've tuned the antenna to resonance is we got to match it to the match the whole system to the transmission line. I use RG8, not RG8X, RG8, 50 ohm coaxial cable. And the way I did the matching to the whole setup was that on the bottom of my coil I had a bunch of taps, and I just tapped up from the bottom until I found something that was close to 50 ohms. Next slide, please. So if we look here at the very bottom, the arrow pointing at the bottom, that's where I tapped up in order to get it matched. And if you look at the top arrows, those taps were put in with the idea that maybe I could actually take this whole setup and by tapping down, get onto 160 meters. And sure enough, I could bring it down to the point where I was able to resonate this little antenna, now bigger in terms of wavelength at 160 meters, in order to get on that band. So it did work. And I had this idea that we put some kind of switching out there, and I didn't do that. Okay, next slide. Now about these, excuse me, resonating and matching improvements. You see this, what you're seeing here is my footprints in the snow. So you can do the math on this one. I got tired of going out in the yard. Honey, where are you going? Going out to tune the antenna. Again. Yes, again. And you know, every time the weather changed, we got snow, rain, ice. Oh, good weather. The antenna's resonant frequency would change. So we'd have to go out there and tune her. And the other thing that would happen is the wind was blowing a lot. Well, I just gave up because you could see the SWR doing this and step with the wind. We're not going to go on the radio today. But I thought, wouldn't it be nice if I had some kind of remote control? I could just sit there in the shack and watch that SWR meter and tweak a knob here, bring it down to 1 to 1. I never got to that. A friend of mine did with a loop antenna, so I know it's easily done. That's something else to try. The other thing I would do, and I think Jason did it with his setup, rather than just tapping up to find 50 ohms and let the imaginary part be what it is, get myself a series capacitor in there so I can tune that out. And that would have been a nicer way to do things. It would, go along with my brain saying, get rid of the losses, kid. Get rid of the losses. Next slide. So, by this time you're wondering, why is this guy harping about losses? Why worry about them? We usually don't worry about this because our HF antennas are big against the wavelength. So there's not much loss involved. Unless you start talking about an antenna stuck on a car, or you have a mobile operation on HF. So why worry? Because if there's more loss, the efficiency goes down, the radiation goes down, and the sensitivity to signals goes down. Next slide, please. So here's the efficiency formula. Now I bring out efficiency equals your radiation resistance up there on the top. And you look below the line, radiation resistance appears again, and then a whole bunch of things in brackets. Show up. So here we have RAD up on top, RAD on the bottom, and if these other ones weren't there, all that stuff in the brackets is losses, or R losses, you'd have 1 over 1, or RAD over RAD, which would come out to 1. Efficiency would be 100%. It'll be some universe other than this one. Unfortunately, what we do have is below the line here, excuse me, resistance of the coil, that big coil that I built, resistance of the antenna, physical connections, and the wire. All those connections that I have in there. And all kinds of other things that I can think of, like moisture building up inside the tuning unit and so on. And if you were to go and look at any of these antennas that I'm talking about today, you would find that the total losses far exceed the radiation resistance. That looks like a nice little math equation. Here's what it means. All the power that's going into that antenna, a little bit is radiated, and the rest is warming up the hardware, warming up worms. Now, if you're trying to grow worms, you're in the right place. But if you're trying to be a ham radio operator on 630 meters, not so much. Next slide, please. So these R losses are much, much greater than the radiation resistance. Efficiency of the whole system, therefore, is much, much less than 1. In fact, efficiencies of 0.005, 0.008, 0.01, 0.01, that's good. We'll see a little bit more about that in a second. May I have the next slide, please? So radiation that we want to get out in space you have to remember that we're limited to 5 watts. Next slide, please. So efficiency equals the desired radiated power out divided by the necessary power input. Next slide, please. So I've rearranged that equation. The old equation from the previous slide is up at the top. And down the bottom of here is necessary power output equals the radiated power that you want to get out divided by the efficiency. Next slide, please. So let's plug in some numbers. Remember that 5 watts? Well, my antenna on a good day probably was running 0.005 efficiency. So if I wanted 5 watts, I needed a kilowatt, which I didn't have. I had 20 watts available to me. So you can then do the math and figure out what my radiated power was. It was pretty low. Nevertheless, we'll see that worked. Next slide, please. So why are these antennas so efficient? It's because they're little. This formula here, if you work it out and you know the height of your antenna and you know the wavelength you're working on, will give you the radiation resistance. Let's just look at the part that's circled, and that is the effective height of the antenna squared divided by the wavelength squared. If those are equal to each other, well, then we get really high radiation resistance, multiplied by everything on the left. On the other hand, if that height gets cut by 50%, then the RRAD, the radiation resistance, drops not by half, it drops to 1/4. So the shorter the antenna has less radiation resistance, not directly, but by the power of 2. Next slide, please. Here's some buildings. Next slide. The one on the far left is the Burj Khalifa. One in the middle is the CN Tower. One over on this side is the Willis Tower, formerly known as the Sears Tower. To the immediate left of the CN Tower is a blue line, which would be the ideal 1/4 wavelength vertical on 630 meters. It would be 157 meters high. Ooh. Not many of us are going to get that unless we have access to an old broadcast antenna that nobody wants anymore. But I don't think there's anybody in the room, and I've never met anybody who's got access to an old broadcast tower and its ground plane underneath, by the way. Now, if we go and look to the right of the CN Tower, the blue object, that is a pretty good antenna for 630 meters. It's 20 meters high. This is doable. Now don't compare it to the CN Tower, compare it to that ideal 1/4 wave antenna. And you can see how small we're actually dealing with here. So a 66-foot antenna is little compared to the wavelength. Next slide, please. Next slide, please. Whoops, you're right, I should go back one. Go back one if you may. There you go. See that yellow arrow pointing there to that little box there next to the ideal, or the 60-foot high antenna? That's my antenna. 8 meters. Now compare that to the ideal over here, and you can see how small my antenna is with respect to the wavelength. It's really inefficient because it's so small. Next slide, please. So again, to drive this point home, why is this guy talking about losses all the time? Because the losses in your system are much, much greater than your radiation resistance. So when you measure the resistance of your antenna, and this applies to most of us who run verticals, That R that we measure is mostly the loss. Next slide, please. I'm talking about measuring the system. This is the stuff that I use. I have a impedance bridge. I also have a VSWR bridge and power meter that I use. I have put an RFM meter in series just to see how much current there was there, but I didn't use it as a day-to-day operational aid. Some people also use phase meters, so they can measure both the voltage and the current and see the phase between the two of them. When they're in phase, we have resonance. And you can also do it with a two-channel oscilloscope if you wish. I always use a relative field strength meter on all bands to see if I tweak something out there, does it make a difference over here? It's really easy to do. Carried one from QTH to QTH to QTH, probably for a good hunk of that 60 years. Next slide, please. You'll also find that you're going to do a lot of experimenting on this band. And your colleagues that you talk to are experimenting to see what works, what doesn't work. Can I send a signal between two rods stuck in the ground? Why not? Will you hear me? Well, let's try it and see if we can hear you. So keep good records, write things down. If something breaks, that'll give you a way to look back. What did I actually do last fall when I put this all together? You know, before you go out there with the snow shovel to clear away at the base of the antenna, you'll at least know where everything is. You're also going to want to talk to other hands about this, so you got your notes available to you. Next slide, please. So we'll look at my system now for a moment, and then I'll step down and Jason will regale you with his setup. So we're going to look at my antenna, tuning and matching unit, the ground, and then go into the shack. So next slide. Now, I wish you could see this a little better than what it is, but what you're seeing in the foreground is the butternut HF9V vertical antenna, and it's over that ground plate with all those radials. And the blue box contains the antenna matching unit for 630 meters, and it's connected to the radial system by the shields from two coaxial cables. And you can barely see it, but the antenna is running from, you can see the top arrow, it's pointing to the top of the antenna, and it's running from that tree, one of those trees way in the background, to a tree about the same distance over here. So about 30 meters in total, a little bit greater than that. Good point here, use good insulators on the ends of your overhead wire, and do not put the ends of your antenna in the tree, okay? High voltage there, tree on fire. And since we had a lot of fires here in Halifax this year, it's going to be frowned upon. The other thing you might notice is I used window line for the vertical part. So it's attached up there to the top of the horizontal part, comes down, and then the feeders are tied together. This is a trick that people have done for years. They put up a doublet antenna, put it through the antenna matching unit, it runs on any band you can think of. And then you short it together, and you got a Marconi T that you run on 160 meters, for example, someplace that your tuner might not be able to get to, or the antenna can't get to. And my idea was, next slide, please. You can see those beautiful insulators there. I hauled those around for years and years, finally got to use them. My idea was, is inside the blue box, I'd put a relay, and I could actually run the antenna on 630 or run it on 160. Wow, I've never been on that band. Well, I did, but it was a long time ago. So that's the box, and next slide. You can see there's a, if you could read all that, there's a transmission line going off to the shack for the butternut vertical, another transmission line going off for the 630 meters. Next slide. So this is what it was in the shack. That's an ICOM 756 Pro 3. And on top of that, to the right, is a monitor sensors transverter. This is an Australian group. Boy, when you open that thing up, what's the first thing you do when you get it, too? You open it up, okay? It's such beautiful engineering inside. It's really beautifully done. And it converts between 630 meters and 160. And you can see on the screen of the Pro 3 that there's a signal there. So signal came in, went through the transverter, was converted to 160 meters, and the reverse when we're transmitting. And to the left is the interface between the radio and the computer. So that's what's in the shack. Next, please. Now, I said there's DX on this band, okay, so there's G0MRF. He's there a lot. He can be an Elmer on this band. He's been around for a while. And I was just thrilled to death, you know, working him after seeing his write-ups on various websites and in magazines. And very quickly, the QSL card appeared in my mailbox. And that's another thing. On this band, people seem to QSL with paper. Maybe it's a bunch of old guys, I don't know. But anyhow, moving on to the right side of the screen is the LA2 XPA. I was really excited about this until I looked him up. And well, he's got this location where there's nobody around, so there's no noise. And he's got an antenna farm up there that is just, you know, to die for. So when I wrote back to him, I said, I'm pretty sure it was your receiving setup that made the QSO happen rather than my transmitting setup. He was gentleman enough not to agree. So moving on to the next slide. Half of the USA was worked in one winter. And all that is effectively DEX, except perhaps for K1BZ. Next slide, please. Here's some DX. Well, at least one of them, the VE3CIQ. And then Glenn, who is also a 630-meter operator who could not be with us today, VE9GJ. Next slide, please. So, now you see me smiling away up here. So, when you see me smiling in that picture, back when I had hair, all right? Operating on this band, making a linear amplifier, making that antenna and the tuning unit and all that just brought back the fun and games of ham radio. All the excitement when I was a kid. Holy macaroni. Listen to those signals out in the middle of nowhere just appearing all of a sudden. And there's just a few of us here. Woo! Not much QRM. So it really brings back the thrill of amateur radio. May I have the next slide? Now I'm going to step down, and we have Jason who is going to continue. And he has his own separate set of slides. So the stage is yours. Where did I put it?
You had it in your pocket there somewhere. All right, there's a new set of slides in the there somewhere. Not that. It's after the fire, yeah. Post-fire slides. It was called HARC. Certainly. Yeah. There we go. Okay. It's extremely sharp. Yeah, okay. So, yeah, so this is generally a very non-scientific relation of my experiences with this band. It's been interesting, to say the least. Not currently on there right now, but the plan is to resurrect a few things in the wintertime. So if you could hit the next slide there. So the first thing I'll talk about is the antennas I use. Obviously this isn't mine, but it's a beautiful photo of what would possibly be the ideal antenna you could have. Hit the next one there. So this is what I put up. So this is a cage vertical antenna with, you can see here, there's a copper ring at the top here. And then I have 3 top radials or top hat wires. That's probably about, I want to say 50 feet high. It's probably more like 40 or 30 or something like that. It varied, continuously varied in height. The only solid point I had was the connection to the tower. The other 2 ends were in trees, so it was pretty rough going for the first little while until I got things kind of tensioned properly. But every time the wind blew or something went on, you were forever fixing wires or making repairs or trying to get things back in order. However, it for the most part worked pretty good. So it's a cage vertical, and I used I think it was 4.5-inch pipe, just ABS pipe. I cut a few slices of it, and that's what I used for spacers here to keep things kind of spaced out. And the copper ring I just made out of a piece of pipe that was just copper tubing. I just bent it in a circle and soldered it together, and soldered everything to it. So yeah, it didn't work too bad. I put the matching system at the base, and just a few ground radial wires, nowhere near enough. Next slide, please. So here is a picture of the matching network. So I had inherited Bill's variometer setup. I found that I needed to modify it quite a bit to get it to seem to work with my setup. So I went with a little different path. So as you can see in the photo here, there's a bunch of stuff sitting on the cover of that blue box, and I was deep in experimentation here. I have somebody had gifted me a few boxes of coils that came out of Nautel. They were throwing them out, so they're part of their broadcast transmitter stuff. That's these white coils here on the ground and things. Very lovely, wound, enameled, and varnished. So I use those, and in part of my experimentations. But for the most part, I settled out with these 2 guys here. It's a pair of variable inductors that I acquired at one of the flea markets. Somebody was, I think it was clearing out V1 Dave down the valley there. Can't remember his call. UJ. UJ had a lot of broadcast equipment scrapped, and I believe those came out of his pile of things. So, came into good use. Next slide, please. I made this antenna matching system. So this is stolen from BBC Engineering. They did a lot of they have a lot of long wave stuff in the UK. So this was a matching setup that they had used on one of their broadcast transmitters. So I made up a miniature version of that for 630 meters. Seemed to work quite well. But generally it was compact enough to put inside the box, and I just put a little extra capacitance in there to help null out the mismatch at times. Next slide, please. Equipment I used. we have two things. So I built a QRP Labs transmitter for Whisper. I was only going to operate Whisper on this band. So I built the little QRP Labs transmitter. I also built the QRP Labs receiver and promptly blew it up by plugging the power cable into it backwards. So I need to fix that. But monitor systems, these guys, same people that made your transverter, they make a lovely little SWR meter. So this is what this is. It's a beautiful little thing. It goes down to 220 or 2200 meters. It would go down to 150 kilohertz, so, or 100 kilohertz, I think. Anyway, so I've been using that with the QRP Labs transmitter. The QRP Labs transmitter only does 250 milliwatts. So with the losses and everything, I can only imagine it's like probably very low picowatts being transmitted off of that whole setup. So it definitely is challenging. Nobody actually heard me at the time I was transmitting, but we can talk about why. Next slide, please. For receiving, I use two things. For the most part, I actually used the 746 Pro. It actually worked really well, and I heard a lot of folks on there. I also used the Flex 6300. It does cover that band. The earlier Flexes don't without a broadcast band filter, but this one here seems to, so it seems to work okay. But actually I found for Whisper, my general Whisper use, I used the 746 Pro. It worked. It was a solid performer, and the Whisper program would automatically put it on frequency for you. So that was pretty good. Next slide, please. So my first overseas contact was this fellow in Ireland, and generally I heard him, he didn't hear me. You can see the amount of stations in the US. There's a lot of stations in the US transmitting, and you'll always hear them. But this is the first person I heard from overseas, so I was pretty pleased about that. Next slide, please. And then the farthest place I've ever heard is this guy here. I did hear a guy, and I thought I had the slide, but I did hear somebody down in Brazil as well on this band, I believe, or down there someplace. But anyway, this was by far my farthest DX contact on 603 meters. Next slide, please. So the future plans. So I like the cage dipole idea. It actually gives you a little more bandwidth, and it gives you a little slightly more efficiency. This is a picture I found online, and generally I threw this together last night, but it's pretty much what I was thinking about doing anyway. So generally I was thinking about putting up a mast of some kind in the middle here, probably just a steel pole or some sort of fiberglass pole, and have that as part of the radiator, and try to get it up at least 30 or 40 feet, and guy it, and then have the caged wires around it. So this gives you a little more bandwidth, hopefully, because it looks like a fat radiator on this band, and then have at least 3 to 4 or maybe even more top hat radials coming off the top. One thing that this doesn't cover, this picture, and is the ground radial system. So my original ground radial system consisted of probably about 10 wires or so of varying lengths. Some of them were 100 feet long, other ones were shorter. I think I was looking at the idea of using chicken wire, and to go with what you were talking about there, the chicken wire idea, and laying that on the ground and spreading it out for about 50 feet in sort of like a square, and just see how that works. And that might be a better solution, because I really suffered a lot from changes in the ground resistance. Every time it rained, every time the sun shone, like you were back and forth to the tuning device all the time. Having the ability to remotely tune your matching device is a huge advantage because every time you turn it on, the match has changed. Every time you go out and look at it, the match changes. If you go out and measure the SWR or your match at the tuning device, and then you go into the shack and measure it again, it will have changed because when you hook up the antenna, the coax to the matching device, that throws everything off. So it's important to have the ability to remotely do that stuff, so you don't have to go out and touch it. Next slide, please. So yeah, my other fantasies are well, not really a fantasy. It's more of a reality. I'm going to try to go for higher power, but if I'm going to go for higher power, I need to improve my antenna system, or like Bill says, you will have a fire or something will melt. The voltages at these frequencies with these low efficiency antennas are huge, and you will get arcing and things burning. The ability to remotely tune the matching network. So I have bought a bunch of stepper motors off of Amazon actually, and I'm going to build some steppers to do all that sort of stuff. So I'm not sure how strong they are, but we're looking forward to trying that out and see if we can automate that process. The ideal thing would be to have an automatic tuning so that as the SWR changes or the match changes, it will automatically tune itself, and they'd use that for the broadcast or the beacon network transmitters. A lot of the airports used to have. I don't know if there's a lot of them left now, but they had an automatic adjustment on theirs, where as the ground changed, then they would automatically match up. And then we have a standalone whisper setup. So I found what I'd like to do is have everything kind of automated into like a little box, and I could put it out there with the antenna matching device or very close to it, so I didn't have to have long runs coax into my house. That was kind of the plan, because if I'm going to put this together again, it will be out in the far reaches of my backyard, and I don't want to spend a lot of time trying to bury a piece of coax through the back neither regions of my property there. And for fun, I was looking at folded unipole antennas, which are apparently used for broadcasting. Might be another option to look at down the road instead of having a cage vertical. Apparently this is a steel mast, and around the outside of the mast, you can just barely see there's a network of antenna wires going up the sides, and they're on insulated standoffs. So apparently, I haven't really looked too deep into that, how exactly it works, but it may be another idea for our thing. Next slide, please. So this is the last picture of my slides. I don't know exactly what the context is for this picture. That is quite the tuning coil, but you best be prepared to find some big coils if you're going to go onto that band, especially if you're going to try to match a very short antenna to it. So that is the end of my spiel. Any questions? Yes, sir? Are we early?
We're almost out of time, but before we leave, I want to thank again Halifax Amateur Radio Club for having us here. And also thank our audiovisual people for getting everything up and running for us this morning.
Yes, thank you very much.
We only have 0 minutes, right? Go ahead.
We have time.
There was 2 CWs, and the rest were, I think, FTA.
There is quite a bit of CW activity down there. It's only this big.
Yeah, it's all over.
So The band, I found it right around 472. I could hear CW there all the time. Yeah,
Bottom.
yeah.
That's it, eh? Thanks you all for listening.
Thank you.
Thank you, everyone, for tuning in to our live today. My name is Jason. I'm with Radio Amateurs of Canada. We have been watching our live stream, and we know that those of you tuning in online, the text is very small. We are unable to adjust that right now, so what we will be doing is adding the slide presentations into each of the live streams so that you can review those slides later on. Sorry for the inconvenience at this time. We'll get that adjusted as soon as we can for you. Thank you very much, and enjoy the rest of the day.
Good morning, everyone. I have the pleasure of, first of all, thanking our previous presenters, Jason and Bill, for an excellent job on 630 meters. It's my pleasure to introduce our next presenter, Dave George. And light's a little thin up here, so Dave is going to talk about answering the call. And a little background on Dave, not being a close and personal friend.